Today we are moving to the expectation function of chapter 1. So this is the third subsection of chapter 1, expectation and expectation function. So as a definition, the expected value or mean of a random variable can be denoted by in this form, which is expected of x. So we can find the expected of x as the formula defined here. When we have the x as a continuous random variable, it is obtained as the integral of x multiplied with the expectation, the random variable function fx. And then if x is a discrete random variable, the expected value is obtained as the sum of x multiplied with the BMF. Okay, so provided that the integral or sum exists. Okay, so if the expected of the function gx in the absolute form is infinity, then the expected of the function gx does not exist. So in order to make sure either the integral or sum exists, it should be smaller than the infinity. Okay, so then we also can find the variance of x using the expected and expectation function. So the variance is defined to be the expected of the term of x deviate from mean mu in square form. Okay, so this one is equivariant. Okay, this formula can be equivalent to the formula as mentioned here. Okay, in the continuous case, it is equal to the integral of the x deviate from mu in square form multiplied with the fx pdf. If x is discrete, then it is the integral form is replaced with the summation form. This term multiplied with the BMF. Okay, so which is also can be simplified, written in this way, which is the expected of x square minus mu square. Okay, so this is the proposition of the expectation function, in which the expectation of this term ax plus b can be simplified as this, in which the expectation of coefficient will be, again, give the coefficient itself a, and then expected of the variable x plus if b is a constant, it will again no change, remain as b. And then the variance of this term will be written in this way, in which you can see the variance of the constant will disappear, and the coefficient of the variable is a square become when you take out from the bracket. Okay, and then for this term we are using the expected value. Okay, so in which expected of x. Okay, I take the value of certain value, numerical value, and this expected value, the formula can be also extended to the expectation function, in which we replace the variable x with a function, example gx. Okay, so in this case you can see that the expected of the term, so we no more use the variable x, but we replace with a function g1x, g2x, and so on. So the same concept apply when we replace the x with a function gx, example. Okay, so as you can see, this is the proposition. So the expected of the form using the expectation function will give you this simplified to this, in which as you can see, the coefficient will remain itself a when you take out from the bracket b, and then the expected of the constant will remain constant itself, and this is the expected of the function, okay, g1x, g2x, and so on and so forth. So if g1x is positive, then g1x larger, okay, the expectation of the function will also remain to be positive. If g1x larger or equal than g2x, okay, then this also apply when we take the expectation function, okay. And if g1x in the interval between a and b, then its expectation function also will be remain between interval a and b. Okay, so this is some idea, okay, how you can the proposition or formula to calculate the expected value and expectation function. Okay, next we move to the example. Example E, we are given a function ux as defined to be as mentioned here, okay, and the expected of this term exists, meaning that it is smaller than infinity, okay. Then we would like to find the value of b, okay, which is the minimum point, okay. So to find the minimum point, we can apply, okay, the expectation proposition. Okay, so we define GB as the expectation of this term. Okay, so this term can be expanded, okay, into the following and then simplified. Okay, so we can write in this form, okay, by applying the proposition or expectation function. And then after that, okay, so this is ex square minus 2be expected of x plus b square, okay, and then this is a constant, so expectation of the constant will give us constant itself, okay. Then to find the minimum point, we take the first derivative, okay, and equalize it to 0. So this is a standard practice. If we would like to find a maximum or minimum point, we have to do the derivative and then equalize to 0 to find the point. Okay, so in this case, after doing the derivative and then equalize to 0, we find that the point is b as the minimum point, okay, then which is the mean or mu expected x. Okay, then to further show that the point is actually a minimum maximum point, we do the second derivative and it gives us a value 2 positive. So from here we are sure that b is the minimum point. Okay, so for here we are able to solve the question showing that b is a minimum